Small steps, Sparks. Small steps. Hey, it's just me today. Ravi's out on a personal thing. Today we'll define how an ant wanders around, and we'll also define pheromone behavior. All right. There's nothing more to add to this conversation, so we'll just go ahead and get started. Let's start by creating a nest class. This will represent the ant colony's nest. Now keep in mind that for a given simulation, we would require only one nest. I'm starting off by creating a constructor. The constructor will declare the position of the nest, which will be random, anywhere random on the screen. We'll also declare a render function that essentially renders the nest on the screen. We'll include the nest in the index.html. And in the main ants file, we'll also declare just one nest. As said before, every ant colony simulation will just have one nest, and therefore we require that one nest variable to be declared. We'll declare it just as an empty constructor. We don't need to pass anything, and then we'll just simply render the nest on the screen. Let's see what that looks like. You can see that the gray blob or the gray circle that you see on the screen is the nest that we were talking about. We want the ant to start from wherever the nest is. We'll first remove the unnecessary constructor argument. We don't need it. And we'll start the position of the ant from the position of the nest. And we can do it this way. Simple as doing that. Now let's see what that looks like. I'm going to refresh the screen a few times, and you will see that the ant starts from wherever the nest was or the nest is. Next, I want to add a couple of functions to the point class. One is a distance function, which is nothing but the hypotenuse, and the next one is a clone function. We want to give our ants the ability to wander around. So I'm going to declare this constant wander strength. For now, it's set as 0.4, and I'm going to set the speed to a random value between the negative and the positive values of wander strength. All right, once we've done that, let's see what that looks like. You'll see that the ant now wanders around to its destination, but I don't really like how weak that wander strength is. So I'm going to change that in just a bit to, let's say, a value of 0.7 and see what that looks like. All right, and now I think the wandering is a lot more better. It wanders around just like how an ant would do in real life. Next, I don't really like that every ant has its own size and body size, so I'm going to declare them as constants for now because I think that's better. So I've declared constants called ant size and ant body size, and all I'm going to do now is remove the size and the body size from the ant class itself and use the constants in place of the size and the body size. So here is me replacing all of the variables. We'd also have to think about having multiple ants on the screen. Now that's actually very easily done. So I'm going to declare a variable over here called the ant count. This will be the number of ants that are available on the screen. And I'm just going to use a simple for loop to declare as many ants as the ant count. So once we've done that, and we quite literally don't have to do anything. I think one thing we need to do is just make sure that when the mouse is clicked, all of the search points are set on all of the ants. All right, so now that I've done that, let's see what that looks like. So this is just a single ant, nothing has changed over here, but let's change the ant count to, let's say, a value 25 and see what that looks like. Much more better. I don't know if you agree with me, but they do look like ants to me. All right. One thing to make them realistically like ants is to reduce their size. We only keep the size large over here because they're much more easier to look at. But once I've made them small, you can see that they literally look like ants scurrying across the screen. If this was full screen, it would look even more better. Here I am clicking the mouse to change their positions. I mean, you'll have to agree with me that this looks very ant-like in behavior. Let's do some housekeeping. And by that I mean I want to keep all of the constants in a single place. So I'm just going to create a constants file. I'm just going to call it ant constants. We'll have to include that in the index.html as well. Now I don't want my ants to wander all the way to the target. I need a way to curb their wandering behavior as well. To do that, I'm going to find out the distance from their destination. If the distance from their destination or their search point is, let's say, greater than 18, only then I'm going to introduce the wander. Now, if the distance is less than a specific amount, over here I'm just using 2, then I'm just going to set up a new point. So what happens with this is that as soon as it reaches its search point, it will just go to the next search point. Let's see what that looks like. All right, so I've refreshed the screen over here. So the ant now wanders to its search point, goes to that search point, and when it reaches that search point, you will see that it now goes to a new search point, which is great, which is something that we want. All right, I'm going to also not render the search point at all. This way on the screen, it will look like the ants are indeed searching. All right, so the search point is no longer rendered on the screen, and you will see that the ant will try to now traverse all the way to the screen. I mean, it will search for everything on the screen. All right, we have given our ants the ability to seek for a target while wandering around. But how long should an ant do this? At some point, we want the ant to change its behavior. In real life too, an ant simply doesn't keep wandering in search of food. This way it will simply die of exhaustion. Therefore, once in a while, the ant returns back to its nest for food or for rest. But how does an ant know its way back to the nest? In real life, an ant uses something called as pheromones. Now what I'm showing over here is the nest. I have the ant, and these are the pheromones that are being laid down by the ant. All right, so when an ant wanders away, it drops these scent chemicals that are just laid down, and when an ant gets tired or needs to come back to the nest, it can simply retrace its way back to the nest using these pheromones. All right, we are using two types of pheromones. One is a pheromone to just mark that the ant is going away from the nest, and we'll call this step pheromones. All right, this way if the ant is lost, it simply needs to look for a pheromone that has the step type in it and then return back to the nest if it is not successful. However, if an ant has found food, then it will lay down a separate type of pheromone that will indicate that this particular ant has found food. So if another ant comes across this pheromone, then it knows in which direction to go for the food. So that's the thing that we are trying to do over here. All right, so we need two types of pheromones. One where the ant just simply lays around when it is wandering about, but once it has found food, it needs a way to tell other ants that the food has been found. All right, so there are two types of pheromones. Now when we are talking about pheromones, right, I mean, they are not there forever. Pheromones are not there forever. They keep evaporating. And every time step, the pheromone concentration of every map point decreases according to this particular formula. Okay, so it's just that the pheromone is 1 minus a constant k multiplied by the pheromone value. All right, in JavaScript, it would look like this. So the pheromone strength is 1 minus a dk constant that we'll declare multiplied by the strength itself. So therefore, it sort of decreases in a very even fashion. All right, let's start by creating a class called as the pheromone class, and it will have a constructor that will pass a position. Pheromones will also have a strength. It's the strength that we talked about in the slide, and this strength will now initialize for 1. Okay, the pheromone will also have a render function, and in the render function, I'm going to use the fill style, and the fill style is going to be the RGBA, where the A stands for the alpha, and the alpha is the strength of the pheromone itself. All right, we'll just use a simple circle to draw the pheromone on the screen itself. And I'll also have a step function, and as discussed in the slide previously, the strength of this pheromone will reduce based on a decay constant. So let's just declare that decay constant. I'm just arbitrarily assigning it to 0.0006. I think this should be a good decay constant. Once I've done that, I also need to include this in the index.html file. All right. So once I've done that, I also need the step pheromones to be an array. And what will happen is that the step pheromones will be added by the ant itself. Okay, but for now, let's just call the step and the render function of the step pheromones. Let's go back to our ant, and what we'll do is that every time this ant walks, we need it to drop a pheromone. But then if we keep on dropping pheromones everywhere, it won't be, there'll be too many pheromones on the screen. So what we'll do is that we'll use the step counter just to determine how far away the ant is gone. And every 5 steps, we will drop a pheromone. That's what is happening over here. A drop of the pheromone is achieved by simply pushing it to the pheromone array. Now let's see what that looks like. You'll see that the pheromone is dropped, and that's what it looks like. That's the color we gave it. All right. We'll just let this run for a while. What I'm looking for over here is the pheromones to evaporate. All right. And it just seems to me, or it just occurs to me, that the evaporation rate that I've given might be a little bit too little, right? So it needs to be a little bit more strong. All right. So I've let this run for a while, and you can see that the pheromones are still there on the screen. So I'm just going to change the decay constant over here to 0.002. I think this should be appropriate enough. All right. So once I've done that, we'll let this run for a while and see if the pheromones evaporate. So the oldest pheromones should decay faster. All right. I'm 100% sure I'm not pronouncing pheromones right. All right, so you can see that the decay looks much more appropriate this time around. We'll also remove the pheromones from the step pheromones array when they have gone below a certain threshold. We are using the JavaScript's array splice method to remove this pheromone from the array. Let's now address the types of ants that you can have. Now I say types of ants, but when in fact I mean that a single ant can have several modes. All right. According to me, an ant can have these 3 modes. It can be a forager, which means it is searching for food. All right. This is something that we have already done. Now, when it has not found anything, it needs to return back to the nest. All right. But when will it return back to the nest? So what we'll do is we've already declared something called as a step counter. All right. So the ant will move and the step counter keeps increasing. And when the step counter reaches a specific threshold, then it will become a returner. And a returner will simply look for the pheromones that it has laid down, and it will return back to the nest. We'll also have another mode that we'll do next week, and we'll call it a foodie. What it means is that this ant has found food and will now return back to the nest. All right, let's declare a couple of variables, which will be the stand-in for the minimum and the maximum steps that an ant can take before it starts returning to the nest. So over here, I'm just declaring them values between 450 and 600. The ant modes are also declared in this structure here. And once the ant modes are declared, let's go to the ant class and create an ant variable called maximum steps. All right, so max steps is a value between the minimum steps and the maximum steps. So once we have done that, what we'll do is that we'll also declare the mode of this ant. Okay, so let's just declare the mode. An ant will always start with a searcher, or I'm sorry, a forager. And all of the existing behavior that we have is foraging behavior. When it searches for food, when it does, when it searches for food and everything, that is all foraging behavior. So we'll just indent all of this code within the foraging behavior if condition. All right. So once we've done that, once the ant reaches a maximum number of steps, the maximum number of steps that we've already declared, then we'll reset the ant to a different mode. We'll set the ant to a different mode. In this case, it will be the returner mode, and we will we'll reset all of the variables that are there in the ant class. All right. Okay. So let's see what that looks like. So what I have done over here is that I've made the canvas or the ant colony a little bit more bigger. I've also made the ants smaller, and I've also introduced a lot more ants, and I've also introduced that fading capability that we've seen in the previous episode. So let's see what that looks like. So you can see, how beautifully it looks like, actual ants that they are actually foraging. But here is what will happen. Once they reach a specific step counter, they will all stop. So you can see that this ant has already stopped, and they all stop between 450 and 600 steps. All right, I'm going to refresh it again just so that you can see the results again. All right, this will be on our website, of course. You should be able to see this, refresh it how many ever times you want, and see the different behaviors that come out of it. Okay, you can also see the pheromones on the screen, and if you wait long enough, the pheromones will eventually decay away, or they will go away. All right. So that's all we had time for this week. Do join us again next week. I suspect that there are at least 2 more episodes on the ant colony system, and we'll see how it goes. All right. Thank you. Thanks for joining. Bye.